Okay. So if it is half yearly, this rate will become half 10 by 2 because it is 2 times. 6 monthly means 2 times in a year. 2 times in a year. So how many times in a year it is going on divided by 2? That will become the 5%. That means 0. You will divide by 0.05. So R will become 0.05. So therefore in the formula what we will do, we will replace R by R upon N. Here N is saying, suppose here quarterly. So for quarterly N will be equal to 4 times. Monthly, for monthly N will be equal to 12 times. And daily N will be equal to 365 days in a year. So N, so this formula, that formula, this one, we have seen when it is annually, this formula is changed to this one. R is in decimal form. Just remember R should be in decimal form. So this only R is replaced by R by N. And this time, yes, time is also multiplied by N. Time, suppose it was 1 year, so we have to multiply by 2. NT, time is multiplied by T is replaced by NT. So the new formula for compounded quarterly, monthly, half yearly, even daily. So we will use this formula to find out. So now we have the questions on this one. Next. Christy invests $300. $300 in an account with a rate 6% interest rate, making no other deposit or withdrawals. What will Christie's account balance be after 20 years? If the interest is compounded semi-annually, I told you that semi-annually means half yearly or semi-annually. So for semi-annually, N will be equal to what? 2. And now you have to use the formula A is equal to P into 1 plus R by N raised to power N T. Here time is 20 years. P is the amount invested, that is P is equal to $300. Okay, and rate of interest R is always converted into decimal. Divide by 100. 6 divided by 100, decimal will move 2 places. This will become 0.06. Okay.
Yeah.
0.06. Then R is 0.03, N is 2 here. Okay, so we can find after how many years? 20 years. So after 20 years, this will be P is equal to $300 and 1 plus rate of interest is 0.06. But here it is compounded semi-annually, so divided by 2, put the value N is 2, time is 20. So 20 into 2, 40. So we have to solve this one. 300 into 1 plus 0.023 is 6 raised to power 40. So 300 into 1.03 raised to power 40. So we can find out 1.03 raised to power 40 is 3 point. It is coming after 5 if we write 4 digits. So the answer is 3.2 5 digits, 3.26203, and multiply it by 300. So 978.61, correct. We are getting 978.61 dollars. So this is the amount when we are taking semi-annually. Okay. If we are taking monthly, I told you for monthly means in a year, how many times it will be compounded? 12 times, because month, there are 12 months in a year, so compounded 12 times. There are 6 times means semi-annually means 2 times. And daily means 365 days in a year, so n is equal to 365. Just you have to change the values here. Just put 300, then this one here you can get 300 into 1 plus 0.06 divided by 12 raised to power 12 into 20, because we have to find after 20 years in the question. So this will be calculated. You will get 900, approximately 993.06 dollars. Similarly, if it is 365 days, so the amount after 20 years will be 300 into 1 plus 0.06 divided by 365 into n into t, 365 into 20 years. So your answer will be approximately 995.94. Okay. Now what we can conclude here? We can conclude that here it is compounding 2 times, here it is compounding 12 times, here compounding 365. So more is the compounding in a year, more will be the amount. You can see here it is 978, then it will become 993, then it will become 995, because it was very small amount, $300. So, but it becomes 3 times more. This is 300, so approximately more than 3 times it becomes, because it is compounded on daily basis. So more is the compounding, more will be the amount. Okay, so now we are doing this question. If $1,000 are invested, so that means this will be the P. P is equal to principal is $1,000. Okay, and saving accounts earning is R is equal to 8% per year. 8% per year means 0.08 value of R. At the end of 10 years, T is equal to 10. Okay. So if we will do it semi-annually first. For semi-annually, N is equal to what? 2, because in a year, semi-annually means 2 times it will be compounded. And the formula is A is equal to P into 1 plus R upon N raised to power NT. Just substituting the values, P is equal to 1000 and 1 plus R, rate of interest is 0.08 divided by N. N is 2. N is again here 2, and it is for 10 years into 10. So we get now 1000. This will be divided to 0.04. So 1.04. It will become 1.04 raised to power 20. Then we can calculate it. 1.04 raised to power how much? 20. So the answer is coming 1000 into 2.19112. So multiply this by 1000. So decimal will move on right hand side 4 places. So your answer will be 2191.1 approximately. This is the amount after 10 years when compounded semi-annually. Okay. When compounded quarterly, so n will be equal to 4. So amount will be equal to 1000, same formula, 1000 into 1 plus rate of interest is 0.08 divided by 4 now. Divided by 4 raised to power, 4 into 10. 4 into 10, n into t. So this will become 1000 into 1 plus 0.02, actually 2, 4 to the 8 raised to power 40. So this will become 1000 into 1.02 raised to power 40. Calculate by the calculator. 1.02 raised to power 40 is equal to 2.20803. Right up to 6 decimals, and then multiply. This decimal will move to 3 places. After 8 it will come, because when you are multiplying it will move 3 places. 1, 2, 3. So this will become 2208.03 dollars approximately amount after 10 years. You can see it is 2191, it is 2200, because it is compounded quarterly. When it is compounded daily, so n will be equal to 365. So amount will be equal to, same formula will be used, 1000. This is the formula that we are using. You can see this, the same formula is applied in all the questions. 1 plus r by n raised to power nt. Okay. So 1 plus r is 0.08 divided by 365 days, and here is 365 days, and for 10 years multiplied by 10. So we are getting 1000 and 0.08 divided by 365 plus 1. Approximately it is coming 1.0002, and then 3650. It will become 3650. So we can find 1.002 raised to power 365. It will be 2.07 approximately. 2.07356. When you multiply this, the decimal will move to 3 places. So 2000, but it is 2073.56. 365. It should be more than 2208. There is a mistake in calculation. Okay, so uh, you can do it by other way. Okay, 1 minute. 365 plus 0.08 equal to this divided by 365. Same thing is coming, and it is raised to the power 3650. 2.225. So this answer is wrong because we have to take more values up to 4 5 decimals. So all decimals in the whatever coming in the calculator, you have to take that decimal, then you will get the exact answer. So I have taken that all the decimals, then I am getting the answer 2.2253 4 and so on. So up to 6 places, 6 digits you can write. Now it will move here. So the answer will be 2225.34. So it is more than 2208. This is 2225. So just see that it should be more than this one. Relatively, it is smaller than this. This is smaller than this, means this is bigger than this. This is more bigger than this, because it is compounding on daily basis. It is compounding 4 times in a year. It is compounding 2 times in a year. So more it is compounding, more interest will be added. Now, as we have seen in the starting exponential function, this is our exponential function. If you remember it, our exponential function is this one.
Yeah.
There was a formula for exponential function. If you remember that E is equal to x, sorry, limit x tending to infinity, exponential is equal to limit x tending to infinity 1 plus 1 by x raised to power x. This is the formula for exponential function. Now we will consider an example, and it will convert into continuous compound interest. Means if it is given that it is a continuous compound interest, then we can do it for any years. It can be asked for, can be calculated for any years. So this is compounding annually, compounding semi-annually, compounding. One example that we did just now, 300.06. When annually done, we got this answer. When it was semi-annually done, we got this answer. Quarterly means 4 times in a year. Monthly 12 times in a year. Daily, hourly also can be asked. If early hours, you can remember this, because in 365 days and 24 hours. So 365 multiply, check 365 into 24, you will get 8,760 hours in a year. Hours in a year. So that's why if it is yearly, we will take 8,600 and 760. That you have to remember when the question will be asked. Okay, so we are going towards another thing that is called continuous compound interest. Continuous compound interest. In continuous compound interest, suppose the interest new compounded continuously, so that there was no waiting period between the interest payments. We can derive a formula by using algebra to manipulate the regular compound interest formula. So if it is given continuously compounding, then this is the formula that we have seen already. This is what formula that we have seen for compounding semi-annually, quarterly. That is R divided by N is equal to NT. Sorry, to the power NT. Okay, and it can be written as, if we replace, first see that we can write this as 1 plus 1 by N upon R. N by R, because if you will take it in the numerator, it will revert. So it can be written as N upon R NT, same thing. 1 upon N upon R means R upon N. That will be the reciprocal of this one. So that's why. Now, if we put N upon R is equal to X here, N by R is equal to, let it is equal to X. So this amount will become equal to P into 1 plus 1 by X, and here you can find the value of N. N is equal to what? X R. R will multiply here. What will be the value of N from this? N will be equal to R X or XR. So this N is replaced by, this is replaced by this one. So instead of N here, we can write XRT. XRT. So that means we got A is equal to P into 1 plus 1 by X raised to power X to the power, because this power is split into two parts, RT, power to the power will get multiplied. We can write this power in two parts like this. And now, as X tending to infinity and tending to infinity also, because X is equal to NR, means as X tending to infinity, N will also tend to infinity because N is in the numerator. So we can take the limit here, X tending to infinity, then this amount will become, this value will become limit N is tending to infinity, because N is continuous, means here N is increasing. Early we can find out more, after early also we can find per minute also, and second, second. So it is going towards the infinity. This N is going towards the infinity. So that is why N is tending to infinity, and when N is tending to, X is tending to infinity, N will also tend to infinity. So we can say that X tending to infinity here, P into 1 plus 1 by X raised to power X to the power RT. What we are doing, we are going to convert into exponential form, this form, the same formula when it is continuous compound interest. In the question, it is not written quarterly, but it is written continuous compound interest. So that formula we are going to drive it, the third one. Now this limit will go inside. This will go inside of it, and we can write it as P outside, and the limit will be written with the function of X only. So X tending to infinity, 1 plus 1 by X raised to power X whole raised to power RT. And now you can see this is the formula for exponential. This is what? This is the formula of exponential. So it can be replaced by E. It can be replaced by E. So we can write P. We can write P E raised to power RT. And we studied about E, value of E, everything. So P E raised to power RT. So what we concluded that we have concluded that for continuous for continuous for continuous compound interest, for continuous compound interest, we can use the formula for finding the amount after 10 years, after 20 years, after 30 years. If the question is given compound interest is continuous, so we can use this formula P into e to the power RT. So as of now, we have seen three formulas. First formula, A is equal to P into 1 plus R to the power T. Second, R upon N raised to power RT. And this is the third one. First one was given for compounding annually. Second was for semi-annually, quarterly, monthly, daily, hourly. Okay. So the next step is we have to do this question. This is the formula that we have derived. You can see this formula that I have written there. This is RT, P into RT. So maybe not visible to you, but this is A is equal to that we have derived already, P into E raised to power RT. So this is for what? For continuous compound interest.